Another thing we can use the altitudes for is to find the orthocenter. And the orthocenter is where all the altitudes meet. So you see how this is one altitude that passes through point C, here's an altitude that passes through point A, and here's an altitude that passes through point B. All of these altitudes have 90 degrees, so altitudes you're working with 90 degrees. And the orthocenter is where the altitudes meet. Okay, and then if this is where the altitudes meet, then we're going to have quite a few congruent angles. So all of these angles, this is going to be 90 degrees, which means this is also going to be 90 degrees, 90, 90, 90, and 90. So angle AED is going to equal the same thing as angle BED, right? They're both 90. And angle CFD is going to be congruent to angle AFD. And angle BGD is going to be congruent to angle CGD. So CFD, that's CFD, and AFD, right here. See? So it's just the other side of that 90. So all of these all equal 90 degrees. Okay? And then the last thing is the orthocenter is not always inside the triangle. If you have a scalene triangle, not scalene, sorry. If you have an obtuse triangle, the orthocenter might be on the outside of the triangle, as you can see right there. Just because certain triangles, your altitude's going to be outside of the triangle. So if the altitude's outside, then your orthocenter will also be outside. All right, so to calculate the orthocenter, I have 3 points. So the first thing I'm going to go ahead and do is graph those points. So let's see. Point A is at the origin, so that's right here. And then point B is at 1, 5. So 1, 5 is right here. So this is A, this is B. And then point C was at 5, 0. So that's right here. And then I'm going to go ahead and connect those to create my triangle. And to find the orthocenter, there's 2 things I could do. Either I can use my ruler and get an approximation of the orthocenter because the edge of my ruler creates a right angle. So if I line this right angle up to one of the lines of the triangle and have it go through the vertex on the other side, then I can go ahead and graph my altitudes, and I'll see where those altitudes meet to give me an approximation of where the orthocenter is. So this one. And then so if I had to use an approximation for the orthocenter, it would be right here, and that's about, that's at about 1, 1, right? So my estimate is 1, 1, okay? So if we get something close to that, we know we did our math right. If we get something that's different, that's way different from that, then we did something wrong with our math, okay? So for the math part, the first thing I got to do is find the slopes. So slope AB, what I'm going to do is rise over run. So my rise, this goes up by 5, and up is a positive direction, so positive 5, and it goes to the right 1. So 5 over 1 is my slope. 5 over 1, that's just 5. Okay, now next we've got slope for BC. So BC, we've got rise over run. So for rise, it actually goes down, which is a negative direction, so it goes down -5, and it goes to the right, which is positive direction. It goes to the right 1, 2, 3, 4. So BC is going to be -5, 4. Why is it negative? Because it goes down. Okay. Next, AC. Well, AC right here, there's no rise, so it's 0. So I found all my slopes. Next, what I'm going to do is I'm going to go ahead and get the negative reciprocal for each of these to find the slope for the line that's perpendicular, because we don't actually just need the slope here, we want the slope for this line that's perpendicular to it. So perpendicular slope for AB, negative reciprocal, so that's negative and 1/5. For BC, we started with negative, so now we get positive 4/5. And for AC, we had 0, so the opposite of that is undefined. And then next we got to write our equations. So for our equations, the equation of a line is going to be y equals mx plus b. Okay? And each line is going to have a point that we actually already know, because we're trying to get the equation of this line right here. The point I know along this line is point A. Okay? The point I know along this line is point C. And the point I know along this line is point B, right? So perpendicular to AB, it crosses with point C. So the perpendicular slope for that is -1/5. So we start with y equals -1/5 x plus b. Now, I said we know point C is on that, so we're going to plug in our points for point Z. So that's 0 equals -1/5 times 5 plus b. And then when we do our math, we get 5 times 1, that's 5, divided by 5 is 1, that's negative, so -1 plus something equals 0. -1 plus 1 equals 0, so b equals 1. So our equation for that line is y equals -1/5 x plus 1. Okay? Next, we need the equation for the line that's perpendicular to BC. So BC has point A on that line. So BC, our slope for perpendicular was going to be 4/5, and we said point A is the point we knew, which is 0, 0. So I'm just going to go ahead and plug it in. 0 equals 4/5 times 0 plus b. What's our intercept? Well, I didn't even have to do the math, but we already see the intercept right here, which is 0. So our intercept is b equals 0. Or I could do the math, which tells me that's going to be 0. So then our equation for that line is y equals 4/5 x. I'm going to go ahead and make that look prettier. So y equals 4/5 x. And then the last one, it was with an undefined slope. But the line we're looking at is this line right here. And that line right here is just along x equals 1. So the equation for that line is x equals 1. So I'm going to call this equation number 1, I'll call this equation number 2. I'll call this equation number 3. I need to use 2 equations to solve for the intercept right here. I like using this whenever I have the chance to use something that tells me exactly what one of my points equals, x equals 1, then that's one of my choices. I'm just going to use that. So I'll use equation number 3, and I'll just go ahead and choose equation number 2. Oops, 3 and 2. So equation number 3 was x equals 1, and equation number 2 was y equals 4/5 x. And now all I got to do is plug in my x to solve for that y. So y equals 4/5 times 1, which is y equals 4/5, which is equal to 0.8. So then the point, like my orthocenter, it's actually at 1, 0.8. Because we got my y, we got my x. And 1, 0.8, is that close to what we approximated it would be? We approximated it would be 1, 1. We actually calculated it's 1, 0.8. Yep, it's pretty close, so we're good.